Hi, happy May the 4th. This is a little meme I found for May the 4th be with you. Today we're going to work with some geometry, and at its very basic. And geometry is one of those things that you need in a lot of careers. That'll be something that you see a use for in a lot of different ways. In fact, I'm wearing my May the 4th Star Wars tie. And these are the schematics, the drawings of the X-Wing. And you see that they've outlined and labeled and done the blueprints for how to build an X-Wing. That's one of those things that they use a lot in construction. The very basic sixth grade level um, geometry, you'll never ever regret knowing this stuff, and it's pretty easy. Most of it is things that you can look up online. That being said, it's a lot easier if you understand where those formulas come from, so you don't have to look it up online. These are super simple formulas, so these aren't things that you would need to look up a lot. For example, we're going to do the area of a circle, but farmers, when they farm a circle and they have an irrigation well, they need to know how much area is in that circle, and you'll have the sixth grade uh, equivalent of that skill. But farmers also sometimes need to figure out the area of their corners. So when you put a circle inside a square, that gets a little more complex, and that's something that you could probably figure out with some measurement and skills there. But that's also calculus, which could be high school or college level mathematics. So let's get started on the area and perimeters formula quiz. Make sure you're paying attention. You don't want to be like this B here. The B on the left has some great little six-sided figures, hexagons, and the B on the right uh, didn't pay attention or was skipping geometry class. So don't be that kid. Don't be that irritating kid that's part of the group that messes everything up. All right. So, and that's a joke for later that keeps popping up there when it's not not expected. So, all right, move my camera over just a little bit so we can see, and let's talk about area and perimeters formula quiz. This is the paper that's in your packet. It says write the appropriate formula to find the area of each geometric figure. Um, if you're in super fast, don't watch the video, cheat, and research off of Google mode, then you just research this, type that into the Google search bar, and write these down. But that doesn't get it to stick in your brain. That doesn't form the connections that you need to in order to go further on. So even though that's something you can use later, and this is a good reference tool for later, this is basically notes today. If you watch the video and you listen to the connections that I help you make, then this stuff stays in your brain. There's a lot of times kids will be like, "But I'm not smart in math." Well, it's not a matter of intelligence; it's a matter of the developmental process of gaining that knowledge, and that's why this is kind of a key lesson to watch, is to see this. So we'll have area, and then down here they talk about perimeter. Okay, so and then on the back side is kind of a matching quiz, and that's something that is just a neat little tool to practice with. Um, and you can what I would do is watch the video, fill this out as we go through the video, and then step away from it till later today. Come back and see if you can match those up pretty easy. This is probably the easier side because all of the formulas are listed and all of the and the shapes. Looks like there was a little alignment error on the printing. But anyway, this is the most important part, and then this is kind of the reinforcement practice later on. All right, so let's get started. Of course, from most of our math minutes and a lot of time in class, we know the difference between area and perimeter. As a quick review, the perimeter of this sticky note is the outside. If I was to draw the perimeter, I would draw it using a pen or a pencil. I want something with kind of a sharp point. If sticky notes were a little thicker, That would have been easier to do. But that's perimeter. Perimeter is the outside distance around. Okay. In class, I told the story about patrolling the perimeter, and you have to walk around the outside. Some years we've done the activity where I say, okay, get up and walk around the perimeter of the table, and everyone knows how to do that. And then I make a horrible statement, say, okay, walk the area of the table, and some kid gets on the table, and we have to calm down and get it under control. So I kind of held off on doing that. To find the area, though, that means everything that's orange on the paper, well, everything that's inside that perimeter. So if you were to color the area, you'd need a highlighter with probably a little wider pen tip, because you would want to not spend all day taking care of the area. So when you are painting a house, oh, look at those great coloring skills. Beautiful. When you're painting a house, you will tape the perimeter. So let's say you have a window. Here's your wall. Here's a window. Boy, that's a great geometric figure, isn't it? Here's your window. Well, you tape, your painter's tape goes around the perimeter of the window or around the trim of the room. But when you actually paint, you cover the area of the room. Okay? That's the difference between area and perimeter. All right, so we've got a basic rectangle here. Basic rectangles all have the same formula, and they found that formula by doing an essential. It's basically just a mathematics multiplication problem, and so you have measurements along the way here, and you can measure your height of this card, right? So this is going up, and that's height, and then you measure your base. So you've got area equals your base times your height. Just a simple multiplication problem. If we were to actually measure this, this measures 3 in height, and its base measures 4. So this particular sticky note, by the way, those are inches. This particular sticky note has an area of 12 inches, and they're square. So if I had 4 inches, sorry, I'm going to do the 3 first. If I have 3 inches, that means I've got every inch. I'm marking off the 3 inches across, and the 3 inches across, and then the 4 inches are going to be vertically. So I've got 1 inch, 2 inch, 3 inch. Let's measure that up here so I have a reference point to draw my line. I'm going kind of fast, so it's going to look a little sloppy. And if you don't make sound effects, you're probably not doing it right. It's hard to hold back. So I've got these square inches. Each of these is an inch by an inch. 1 times 1 is 1. And inch times inch is inch squared. So each of these are a square inch. Well, there's 4 here, 3 here. 4 times 3, there's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 square inches here. So that's how I'm describing the area that's being taken up, right? Now, if you wanted to do perimeter, then you have to count the distance from each one. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the perimeter is actually 14 inches, and it's linear. It's just 1 inch, so it's not squared. Okay, these are squares, but perimeter is just one line, right? It's just going on the one dimension. All right. Hopefully that's a pretty quick but accurate review of perimeter versus area. Area of a rectangle is always base times height. That's for a rectangle. But a lot of people will call it length times width. I do that often in class. Length times width is the same thing. As you notice, if you're looking at your screen up, this is a height because it goes from the bottom of your screen to the top of your screen, or towards the bottom, towards the top. And this is across the other. But this is actually sitting on my desk, So the height of that card, if someone says, how tall is that card? That's a little bit trickier, because are they talking about this, or are they talking about the actual amount of space it sticks up off the table, or off the paper in this case? So length times width is also a good representation of it, but this is a two-dimensional object. We only worry about those 2 dimensions. Okay. Sometimes they call it side 1 times side 2, but you rarely will see that. By the way, these are little subscripts that indicate what that side 1, side 2, that way you don't have the same ones. So rectangles always have the formula base times height. On your paper, you would write in the area of a rectangle, and you're going to just simply write A equals length times width. Okay, if you want to, you can put the base times height down here, and that works out well too. Okay, I'm kind of a stickler. I really like you to put A equals. I want this part here. I know this is the important part. This is answering the question, but I like this part here because it goes along with equations. And in 6th grade, we learned to work with equations, so that works really well together. You do sometimes have special cases. So you have a rectangle that is a regular rectangle, and regular in the geometric world means that all the sides are the same. So I'm going to mark this sticky note, and I'm going to use the greatest scissors ever. I took these back from school. These are the same scissors that my mother gave me in junior high, and I've kept since then because they are the best scissors ever. I hope that sometime in your life you have something as important as those scissors to you. So as you can see, this is a square. I've made it 3 by 3, right? Well, squares are a little bit different formula. You can use it base times height. 3 times 3, this is 9 inches squared, right? So area is base times height equals 3 times 3, which is 9 inches squared. 9 inches squared. So that's my area. But since the 3 and the 3 are the same, or all the sides are same, and that's understood about a square, a lot of times you can use this formula right here. Area equals side squared, side times side. When we talk about square numbers, 3 times 3, 4 times 4, if you set up just a regular multiplication chart, let's do one of those real quick like. So I have 1, 2, 3, 4, 5, and I have 1, 2, 3, 4, 5. If I set up this, if I set this up real quick, I have 1, I have 4, I have 9, I have 16, and I have 25. If you notice, these are all squares. So these are my square numbers, right? These are the square roots of the square numbers. So squares have equal sides. Square numbers work out that way. Okay, we've gotten a pretty messy paper here already, but I want to use this same rectangle here to demonstrate the next part. So we have 2 formulas listed already. Better get that down on my paper too. We have area equals length times width. Square could be the same thing, but it's got a kind of a special formula where you just square the sides. So if you know that you have a square pad of concrete that you need to put an oil well on, and it measures 100 yards, well, then you know that the area of that is 100 times 100. Okay, that would be an easy thing to figure out without Googling the formula, because that would be kind of silly on a job site like that. All right, so if you were to take this rectangle, this is the sticky note card, right? And you were to draw a line right down the diagonal from point to point here, where you're basically cutting that sticky note in half, right? These are equal parts. Here is, I cut it the wrong way. I drew my line on the wrong direction. Let's do this one. And normally I would just flip it over, but the sticky's on this side, so it'll stay down on the paper. Okay, so here we go. We have a half of a triangle, or half of a rectangle there, right? So the triangle, the area of the triangle is the base times the height. But it's only half of that, see? If it was base times height, here's your height, here's your base, here's your different lines here. So we're going 4 across, 3 down. We're going to end up with how many of these squares? Well, what's half of 12? You're going to end up with 6 squares. Here's 1, 2, 3 full ones, and then these parts will add up to the others. And I know that because when I put both of my triangles on there, 2 triangles add up to base times height. So right now the area of this that's being taken up here, if I line that up better, the area that's being taken up is base times height. But if I only want half of it, then I just take half of that, half times base times height, right? Or that's the same as writing area equals base times height divided by 2. Okay, you could write it this way too, base times height divided by 2. But the most common one is the one that I want you to write on your paper. The most commonly written is area equals 1/2 base times height, right? Well, most people don't even put that dot in there. It's 1/2 base times height. So you find the base, you find the height, you multiply those together, and then you cut it in half, like we did with the 12. All right, so that's how the triangle formula came about. Parallelograms are a little bit different. Parallelograms, you remember, are basically a rectangle that's been squished. So as an example of a parallelogram, you would have a parallel set of lines here, and then you'd have a parallel set of lines here. And so it's a rectangle, but it's been set on one side, it's been squished. All right. Another way to do that, start with your triangle. Start with your rectangle, which is 2 triangles. When you cut it in half, you can actually make a parallelogram out of it. So you can see that that's my parallelogram, or very, very close to it. And because of that, you see I didn't cut off any extra from the sticky note. Everything that started with the sticky note, everything that started with that rectangle is still there. So this is the exact same area of the rectangle, right? The problem that you'll find is that it's a little bit trickier to find. In this case, we know the height. It's still 1, 2, 3 inches. But this, you don't want to find this. You want to find the length. This is actually the true length of a parallelogram. So that would be 1, 2, 3, 4. And it's not the half anymore. It's both parts. So it's really area equals base times height. The part that's tricky is finding, okay, height is easy on this one, but you had to make sure that you found the length. Well, this isn't that hard when you write it like that, but if you were to look at this problem, or this parallelogram that I drew up here, you know the base, whatever that would measure into. Let's just pick a regular number out of the air. Let's call that 7, right? So that's your length, or your base. Base is 7, but we don't know our height. And a lot of times when you're given a problem like this, they draw a dotted line to show the height, or it's over here, because your height is based off of the distance between these 2 parallel lines. And so let's say that ends up being 4. So then you'd have 7 times 4, which is 28. Okay? Again, it's just 2 dimensions. It's finding the base and finding the height, but on a parallelogram, it's not quite as simple. Here's the same parallelogram, but this time you're looking at your height and your base. Okay, not quite as simple as a rectangle, a square, or a triangle. So here's parallelogram on our paper. We're going to do area equals base times height. So that actually is the same formula as over here. Area equals base times height. Okay. Circle, we're not going to get into a circle very much. I don't think we will do that until, well, tomorrow we'll talk a little bit more about a circle, but circles are kind of special. They are an area formula that's based off of the number pi. We've talked a little bit in class about pi. Pi was found, it exists in every circle. It's found because of the relationship between the radius and the circumference, or the diameter and the circumference, if you want to see that. Anyway, here's area, and it's pi times the radius squared, or pi r squared. So now that we've done that, it's time for the little video, or the little picture here, the little joke. Pi r squared, and someone's marked that out, and they put pi r round. That's a grammar joke too. That's something that we would talk about more in class someday, or if we were around Pi Day. Pi Day in the last few years has kind of revolved around spring break, and then our spring break got kind of messed up this year too, so we didn't celebrate Pi Day like we would normally do it, although we did get the oatmeal cream pie, so there's a bonus there. All right, trapezoid. Now you remember a trapezoid is a little bit different critter. A trapezoid has two parallel bases, but then these sides angle in towards each other. So one set of parallel bases, but not the other. Okay, this is base 1, this is base 2, and then these are your sides. All right, but you still have that height. That's your height, right? Oftentimes, if you're trying to find the area of a trapezoid, I'll draw a little bigger one here, then you can do a special trick if you know the measurements, and you can just cut it into two triangles. Then you have the area of a rectangle, and then the area of a triangle, and the area of a triangle. So you have two triangles and a rectangle that you can combine right there. All right, so sometimes there's an easier way. Well, all the time there's an easier way. So for this trapezoid, they're going to use, you see that you've got two bases, and so they use that in their calculation. They're going to go, the area is 1/2, that's your triangles, of the two bases, base 1 plus base 2 times the height. Now, what this segment of the equation actually represents, remember all that work we did with averages? This is actually finding the average of the two bases. So there's base 1 and base 2. You add them together and divide by 2. You're actually finding the average of the bases. So it's 1/2 of base 1 plus base 2 times your height, right? Some people, remember it's multiplication, so you can change the order in which you work the problem. Some people will choose to go 1/2, especially if your height is easy, times height times base 1 plus base 2, and that's legal too. You can move those around within the equation, but this is where it comes from. They're averaging those two bases together. So for a trapezoid, we're going to write area equals 1/2, and instead of base times height like we did on the triangle, we've got two bases, base 1 plus base 2 times height. Okay? So hopefully, as you're going through this and paying attention really close, you're seeing that there is a progressive development of where the formulas come from. It's not just, they didn't just discover it one day and say, oh, that works. There was actually a process to developing these formulas and then using them. And this is very basic stuff. So not the understanding of it, but the application of these formulas. Okay, so this is the part that tricks people up a little bit because they think it should be harder, but it's really not. It says, tell how. Notice I didn't say find a formula. It says tell how to find the perimeter of each geometric figure. Okay, well, how did we find the perimeter of a rectangle? Remember when we found the perimeter of this rectangle? We just measured it and counted up the sides, right? Counted up along the sides. So you can just basically add all the sides together. We are going to assume that you always measure. So step one is always measure it. But in most of the problems that you'll be seeing over the next couple days, they're giving you the measurements for everything already. So if you look at tomorrow's work, I'm trying to get it over here, and my fingers aren't working great. You can see that they've given you all of these dimensions there, right? If you're looking down here, you're like, oh my gosh, we have to do that? It's not that hard, and I'll work with you tomorrow in the video on that too, but you just basically take this and you plug in numbers for it, and then you solve the arithmetic. So that shouldn't be hard. So step one on all these, measure it. Rectangle, you're just basically going to add side 1 to side 2 to side 3. You can go as side 1 plus side 2 plus side 3 plus side 4. On a square, you do the same thing, but the cool thing about the square is that all the sides are the same. So you can do whatever that square is. When we figured our square up earlier, we had 3 by 3, so we just could do 4 times 3, or 4 times the side measurement. Okay, so that actually has a formula. You can go 4 times S. Okay, or if you really had to, you could go side 1 plus side 2 plus side 3 plus side 4, but it's still all those sides added together. Okay, parallelogram. Now, in a parallelogram, we talked about finding the base and the height. This time, you're measuring the base and the sides. So you've got your first base plus your second base plus your side 1 plus your side 2. Okay, those are how you would add all that up. For a triangle, you just add all the sides. Side 1, side 2, side 3, because a triangle has 3 sides, right? Rectangle has 4 sides, square has 4, parallelogram has 4. Circle doesn't have any sides, right? So you have to find the circumference of a circle. And then that would be a measurement issue, and we'll get to that in just a second. I put my paper in the wrong place. Okay, and then a trapezoid is, again, it's a four-sided figure, and you would just add up base 1, base 2, and the different sides. Parallelograms and trapezoids are similarly related. So especially when you do the perimeter formula, so base 1 plus base 2 plus side 1 plus side 2. Okay, I hope a few of you are talking out of the side of your mouth and you're saying, but he said we didn't have to worry about formulas. How am I going to remember all that stuff? Well, all this stuff, these formulas, aren't necessary at all. In fact, if you look on the back side, the options that I've given you for area and perimeter are to basically add all sides. Square, add all sides. Parallelogram, add all sides. For a trapezoid, add all sides. And for a triangle, add all 3 sides. Okay, these all have 4. Now, for a square, I still think just multiplying by 4 is easier, so the formula for this would be easier on that. So that's okay. Now on a circle, there's that relationship between your circumference and your radius and diameter. And so your formula there needs to be that the circumference, or the perimeter of a circle, we should probably write that, perimeter is the same thing as circumference. And in geometry, they like to capitalize that because the circumference equals 2 pi r twice the radius times pi, or 2 times the radius. Remember, the radius is half of the line through the circle. We'll talk about that more tomorrow. Then that is the same thing as 2. Yeah, that was wrong. your circumference, I'll have to get some white out and fix that. Your circumference is actually pi times your diameter, because d and 2r are the same thing. Diameter is the same thing as 2 radii. Okay? All right, so that's pretty much that covers all of the formulas and how they came about. I know we skipped over the circles, and I should probably do a supplemental video at some time talking more about circles, but that's further down the road. If you look at this paper for tomorrow, or sorry, not tomorrow, this is part of today's assignment. Earlier in the video, I said that this is a good review after you've done your formulas. So I would do that. I would finish this up, go eat lunch, go jump on the trampoline, go bother your little sister, whatever, and then come back to this and see if you know that knowledge. Okay? As always, email me if you have any questions.